This video is going to cover how to find all the zeros. So just as a refresher, if we have x minus 1 equals 0, we would solve for x by just getting x isolated. So plus 1, and we would have x equals 1. If we have a trinomial, we would need to factor. So we think about, can we factor? So we have x split up, and I'm looking for two factors that multiply to a negative 15 and add together to a negative 2. You can use any method you want to help you with that. So I know I want them to multiply to negative 15 and add to 2. So I think about my factors. 1 and 15 wouldn't work. 2 wouldn't work because it doesn't go into 15 evenly. So 3 and 5 are my next ones. And I know that they'll multiply to 15. And if I figure out my signs, I can do a negative 2. Well, because I need it to be a negative, my largest one needs to be negative. So I have negative 5 and positive 3. That is set to 0. And then each piece is then solved for my 0. So I would add 5 to both sides. I'd get x equals 5. I would subtract 3. X equals negative 3. All right, so that's just a little refresher. We're going to go into some indifference of cubes. So you're going to be given a little formula to kind of help you with the template of how they should look. And when we think about something with cubes, think about if we have something that's like a cubed. To undo a cube, we can take the cube root. So these cancel out here, and you're left with just a. Same thing if I did b. b to the third power. To undo something cubed, I take the cube root, and I have just b. So we're going to talk about when we have a sum of cubes. So here is our a plus 3, or a cubed plus b cubed, and we're going to think about taking the cube root of a cubed, so we have a, the cube root of b cubed, we have b. Notice that I have what's left, and then to get the other piece, a trinomial piece, we square a. We have opposite signs when we're adding, so opposite a times b, so ab, and then the b squared. So this is your template formula for when you're doing sum of cubes. Now for difference of cubes, we still take the cube root of a cubed and the cube root of b cubed. The sign stays the same. Then we square the a term. The sign is opposite than what we started. Then a times b, then b squared. And because we're doing a negative b times a negative b, we get a positive b squared. So take a moment to really look and understand when we're doing sum, we have a positive in our first binomial and a different sign in our trinomial for our middle term. When we do difference, we have still a negative in our first binomial, but then all of the signs in our trinomial are positive. All right, so we're going to do a couple examples here. So I have x to the third, and I have a negative 64. So I have subtraction here, so I know this is a difference, and x cubed is a perfect cube, and so is 64. You think, what times itself 3 times will get me 64? So you're really just taking the cube root of x and get x, and the cube root of 64, and what times itself, and you can think about 64 raised to the 1/3 power, is going to be 4. So when we set up our binomial, or our format here, our first binomial is going to be the x. Because it's a minus, we have to have a minus 4. Then our trinomial part will be this x squared. The next piece, because we're starting with negative, it's opposite, so plus, multiply 4 times x, we get 4x. And then a negative 4 times a negative 4 gets me a plus 16. So that's how you would use the formulas to set it up. Notice we didn't have a GCF in this, so I didn't pull out anything first. But on this next one, we do have a GCF. If I look at 8 and look at 1,000, I know that my GCF is 8. So I can pull that out first. So if I factor out an 8, I get x cubed plus 125. Now from here, I can use my sum of cubes and go ahead and set my piece up. So the cube root of x is x. The cube root of 125 is 5. I'm doing sum, so that's why I have an addition. So then I square my first term, my a term, x squared. Because I have addition, I'm doing opposite here. Multiply 5 times x. And then 5 times 5, or 5 squared, is 25. Do not forget to bring this 8 down in front, or it will be incorrect. So those are factoring those out to our form of sum and difference of cubes. All right, we're going to do a couple in this section, and so we'll start with number 1. Notice that we have a perfect cube and a perfect cube. This is the same exact one that we've already set up here right before. So we're just going to rewrite that. X minus 4, x squared plus 4x plus 16. And then we're trying to solve for all the zeros, which means we have to find what x equals for these factors. So we are going to set each piece equal to 0 if it's fully factored. So x minus 4 is fully factored, so we can set it equal to 0, and we would get x equals 4. However, if we look at the trinomial, it does not factor. There is nothing that we can use factors of 16 to add together to get 4. So we are going to have to use the quadratic formula. Okay, so we're going to use the quadratic formula right here. So quadratic formula is x equals, and you should know this by heart, negative b plus or minus the square root of b squared minus 4ac over 2a. Knowing that this is your a, this is your b, and this is your c. So let's go ahead and plug in what we have. So we would have x equals, our b is 4, but we put it in as a negative 4 for the formula, plus or minus the square root of, again, 4 squared minus 4 times the a is 1 and c is 16, all divided by 2 times a. That is just plugging in my values. You can use a calculator to help with some of these bigger numbers. So my next step, I would have negative 4 plus or minus. I'm going to simplify what's in the radical sign, and I can do that with the calculator, and I get negative 48, and then over 2. Now for here, I need to simplify what's in my radical. I can't leave a negative there, so I'm going to go ahead and see what would that be. Well, I know that a negative inside a square root is going to come out as an I, so you could do the next step is just pulling out the I. I usually do it in one fell swoop, but it's fine either way. And now I'm going to look at just 48. So think about what factors will work, and I'm looking for like perfect squares. So if I think about my perfect squares, I know that 16 times 3 will get me back to 48, and 16 is a perfect square, and the square root of 16 is 4. So I can rewrite now as x equals negative 4 plus or minus 4, because that's the square root of 16, I square roots of 3 over 2. Now, from this point, you can simplify these pieces. This can be divided by this and this. We don't divide into the 3. This is like a whole term here. So we would end up getting x, and this would be minus 2 plus or minus 2i square roots of 3. And we got rid of our 2 because we divided. So we would have this as an answer. So when we're finding all our roots, our first answer would be x equals 4. And then we have 2 answers within this. This is x equals a negative 2 plus 2i square roots of 3. And x equals negative 2 minus 2i square roots of 3. Because we have this plus and minus right here, that's 2 actually solutions. So notice we have 3 total zeros. And if we look at our beginning piece and we think about the fundamental theorem of algebra, it tells us if we have a degree of whatever, so we have a degree of 3, that we'll have that many roots or that many zeros. And so we had a 3 and we have 3 answers, so we know we're on the right track. All right, we're going to look at number 4. I want you to try it first, see how you do, and then you can come back and check yourself. So with number 8, you should have saw that you have a GCF of x. So we factored out the x, and we're left with 8x cubed plus 1. We can then use our formula for, this is a sum of perfect cubes. Broke it down into the cube root of 8x cubed and got 2x. The cube root of 1 is 1. And then we used our formula. So in the first one, we set x equal to 0 because it can be a root, so x is 0. The 2x plus 1 is fully factored, so we set it equal to 0, and we found that we have another root at x equals a negative 1/2. And then we use the quadratic formula for the other one to solve, and we have 2 answers there highlighted. Notice that we started out with something to the 4th power, so we should have 4 roots, and we do. All right, we're going to move on to using some synthetic division to help us get some polynomials to quadratic polynomials. So we're going to look at finding all the zeros for cubic and higher polynomials with middle terms. We're going to use synthetic division to break down the polynomial into a quadratic polynomial to help us find all of the zeros in the polynomial. So we'll look at number 1 here. It says find all zeros for this polynomial if x minus 8 is a factor. So when it says it is a factor, we should know immediately that there will be no remainder. Okay, so that kind of tells us and helps us know what we should get. So then we're going to set up our problem, look at what our starting degree is. We have a 3, so that means we should have 3 answers. And so we're going to check and make sure we have a placeholder for everything. We got 3, we got 2, we got 1, we got a constant. Fantastic. We're going to use synthetic division. So x is going to be an 8. 8 goes in our box. Then we have our coefficients of our polynomial, 1, negative 4, negative 29, negative 24. And now we're going to bring down the first coefficient, and we're going to multiply and then add the products to each piece. So 1 times 8 is 8. Add those together, we get 4. 4 times 8 is 32. 32 and negative 29 is 3. 3 times 8 is 24. And then that becomes 0, which is great because we were supposed to have no remainder because this is a factor. So this is our remainder. We started with x to the third, so that means this will be x squared, x, and this would be our constant. So now we're going to rewrite that equation that we have. So we have x squared plus 4x plus 3, and we know that it has no remainder, so we don't have to have any extra, and we're going to write this to be able to solve. So we always have to set it equal to 0. Well, we're going to factor this. Well, this factors pretty easily. So we get x and x, and then we have a 3 here. So the only thing to make 4 would be 3 and 1, positive and positive. So now we know that we can set each of these pieces equal to 0. So x plus 3 equals 0, and we end up with x equals negative 3. X plus 1 equals 0, and we end up with x equals negative 1. And we already know that x minus 8 is a factor, so we also have a root of x equals 8. So our answers here are roots are 8, negative 3, and negative 1. We can write those as true roots or coordinates. So 8, 0 is a root, negative 1, 0 is a root, and negative 3, 0 is a root. And those would be your answers. All right, we're going to go down and look at number 3 for a second. And notice that it says we're going to find all the zeros for this polynomial if the graph bounces at 1, 0. So if it's bouncing, that means it has that parabola shape, and that means there's actually 2 things happening there, and multiplicity is 2. So we've got to think about that as at 1, 0, we actually have x equals 1 and x equals 1 twice. So we have no remainder twice, okay, because it bounces there. Okay, so what this would look like, we're going to make sure that we have pieces for everything, 4th, 3rd, 2nd, 1, and a constant. And we're going to use our 1 here, because it is a root, for our factor. So 1 is in our box. Then we have 1, negative 2, 10, negative 18, and 9. Bring down the first. And we're going to multiply. So 1 times 1 is 1. Add together, we get negative 1. Negative 1 times 1 is negative 1. Then add those together, we get 9. 9 times 1 is 9. 9 and negative 18 gives me a negative 9. Negative 9 times 1 is negative 9, and we get 0. All right, so what we have here now is we started with the third, so this is the third or fourth, and we got to do third, second, first, and our constant. So for this piece here, we have x cubed minus 1x squared plus 9x minus 9. Now from here, we've got to do it again. So we've got to see what in the world happens again, because remember, it's got no remainder twice. So we're going to then use synthetic division and find this again for the second x equals 1. So we'll have another problem set up with 1 in our box, but this time we're using these coefficients here. So we end up with, we got a 3, a 2, and a 1, so we're good on that. So we're going to have a 1, negative 1, 9, and negative 9. Bring down our first term. We have 1. 1 times 1 is 1. Add them together. We have 0. 0 times 1 is 0. Add these together, we have 9. 9 times 1 is 9. Negative 9 and 9 is 0. And we should have no remainder because it does bounce there. So we now know what that we're correct on that. So now we got to write this equation, what's left. So we started with a 3 for this particular one. So that means this is 2, this is 1, and this is the constant. So we would write that as x squared plus 9. And now we can solve for the other two roots. So we have to solve and get this along. Well, I can do minus 9 minus 9. And I have x squared equals 9 and negative 9, and take the square root of both sides. Well, I know that square root of x squared is x, and I have a negative in there, so I know it's going to come out as an I, and the square root of 9 is 3. So I'm going to have plus or minus 3i, and that's actually two answers, and I can write that as x equals 3i and x equals negative 3i. In the very beginning, I started with a degree of 4, so I should have 4 answers, and I do. So these are a little tougher because you had to do in a succession to find them. Now to write those as our roots, we can write them in coordinate pairs. So 1, 0, 1, 0, 3i, 0, and negative 3i, 0. So when you tell me what the total roots are, you should be putting them in coordinate pairs to show me their true roots. There's a section in your homework that you will need to find the real rational zeros in your calculator or on Desmos to then use synthetic division to find an equation and then be able to find all the solutions that are not real rational zeros. So we talked about using the theorem the other day and plugging it in, but you were just trying to find a real root. So you can use a calculator for this. So I just put in this one equation, the x cubed plus 3x squared minus 14x minus 20, and graphed it. And notice that if I touch it, I can see that a real root is negative 5. And I look here, that is not a real root because it's a decimal. And then here, it's also a decimal. So when I work the problem and it asks me to find the real rational zero, I can put it in Desmos or a TI-84 calculator and find the root. So I'm going to use negative 5 in my box for synthetic division. And then that'll allow me to make a new equation. Then I'll be able to factor and find the other roots in the real form, not as a decimal. I need to know them in imaginary form, it may be, or it may be something with a square root, but I need more exact than just a decimal that's been rounded. So for an example, if I were having something like this problem, x to the fourth minus 5x squared minus 36, and I look and I touch my roots, I have a negative 3 and I have a positive 3. So in that case, I have two real roots, so I'm going to have to do synthetic division with one of the roots first, get a new equation, then use that information to set up another one with the other root so I can get down to my formal piece. So this is like number 11 through 16 on your homework. So we'll look at one in class, but I want you to be aware of what that looks like. So let's take a look at number 12 on your homework. So we've already looked at this one in Desmos to find its real roots, and this is the one that had 2. So we had a real root at x equals -3, and we had one at x equals 3, real rational roots. So we're going to then take whatever one we want to start with, and we're going to use synthetic division to find an equation and then move from there. So first we want to check, do we have everything we need? We have a fourth. Oh, we're missing a third, so we're going to add a 0x to the third. We have a second, we're missing a first, so we're going to add a 0x, and then we have our constant. So we're going to use, and I'll just pick the -3 since I wrote it first. So we're going to do a -3 in our box, our coefficients of 1, 0, because we had to add it there, -5, 0, and -36. Bring down our first term. We have 1, we're going to multiply, add them together. Multiply negative times a negative gives us a +9. Add those together, we get 4. 4 times -3 is -12. Add those together, we get -12. And -12 times -3 gets me 36. And I have no remainder. Now, I'm going to write this equation. We started with 4, so this is going to be x to the third, x2, x, and our constant. So we have x to the third minus 3x squared plus 4x minus 12. Now, we need to go further to be able to get something that we can factor. Okay, so we're going to go further down, and we're going to use our other real rational root and do the same thing. So we're then going to do, using 3, use a different color here. So we have 3, because we're using this other root here. We have a 1, we have a 2, we have a 1. All right, so we're good with our pieces. So we got 1, -3, 4, and -12. Bring down our first piece. Then start multiplying. 3 times 1 is 3. Add those together, we get 0. 0 times 3 is 0. Add those together, we get 4. 4 times 3 is 12. Add those together, we get 0. Remember, the last term is your remainder. We started this time with a 3, so that means this has to be a 2. This is the 1, and this is our constant. We don't need to write the 0x in our final equation. We have x squared plus 4, and no remainders, and we're going to set it equal to 0. Now we can solve for our other 2 roots. So this is factorable or solvable. So I'm going to go ahead and move my 4 over. I get x squared equals -4. Take the square root of both sides. I end up with x equals perfect square here of 4. The negative means there's an I, so I have 2i, and that's going to be a plus or minus because it's in the square root. So my final answers are x minus 3 and x equals 3. Those were roots that were real rational. And then I also found out that I have one at x equals 2i and x equals -2i. So originally I started out with a degree of 4, which means I should have 4 answers, and I can show you now that I do. So on Desmos, we couldn't see that that was 2i or -2i. It gave us some kind of decimal that's rounded, so that's not exact. We can't just look at that and be like, oh yeah, they're there. We have to be a little bit more exact about what that is. Hope that helps.